I'm going to talk quite a bit in these next few videos about the regulation of mean blood pressure. This is incredibly important because we want to maintain blood flow to our tissues and back to the heart. We need to continue to have that venous return, so to have continued function, continued cardiac output again. So we need to maintain a baseline, don't we want blood pressure to drop too low. So we've got a lot of mechanisms to keep it from, well, to raise it when it drops. We don't have as many actually to address increased blood pressure. And this is um, likely one reason that high blood pressure is, an issue in our society. Our I don't like that. Okay. So I'm going to talk quite a bit about the regulation of mean blood pressure in these next couple of videos. So maintaining mean blood pressure is incredibly important to maintain blood flow to the body for tissue perfusion, as well as returning blood to the heart at the end of that circuit so that blood can be pumped out to the body again. So to have continued function, we have to have um, pressure. Pressure is necessary for flow. Maintaining blood pressure is a incredibly important maintained variable. Heart rate, cardiac output, peripheral resistance are things we've talked about already, some that can dynamically change to regulate blood pressure. They themselves are not regulated variables, they're not maintained homeostatically like blood pressure is. So maintaining blood pressure within a range, the typical range, is a homeostatic process. So let's talk about the factors that influence this. Some we've mentioned already. So some of the short-term ones, the quick regulation of blood pressure, these tend to be the nervous system. There's some exceptions where the endocrine system can regulate like resistance, but in general, quick, and this is true with most things in our body, quick things responding is nervous system, whereas longer term is our endocrine. Endocrine is going to control the targets in that case. So we've talked about some of the short-term effects already, or targets and the responses. So cardiac output, right, is a big one. The two main ones are cardiac output and systemic vascular resistance, also called total peripheral resistance. With the heart unit, we talked about cardiac output quite a bit, heart rate and stroke volume regulated in order to alter cardiac output, and those things alter mean pressure. Mean arterial pressure is a function directly of cardiac output and resistance. Um, Total peripheral resistance, we've talked about, is influenced by viscosity, length of the tubes, and then diameter of the tubes. And the main one that varies that we can control is that diameter. So the autonomic nervous system is going to be the specific component of the nervous system that regulates these things. More specifically, this is pretty much review the sympathetic nervous system regulates all three of those. Parasympathetic, on the other hand, only regulates heart rate. We'll talk more about, so we've done this with the heart already. We have not talked about this. So we'll go into how the sympathetic system alters diameter of the blood vessels. We'll do that. Then long term, how does that fit in here? Well, the other thing that affects mean arterial pressure, well, it's actually not another thing. It is a component of cardiac output, right? A component of cardiac output is blood volume. So what is the volume that we are pumping through here? So the endocrine system is what regulates this. It's going to also involve the kidneys because the kidneys are what process and make urine or retain fluid instead of making urine to maintain blood volume. Maintaining blood volume is going to maintain blood pressure. Okay, lots of hormones that I'm not going to name right now, but lots of hormones involved in this, um, most of which alter blood volume, a couple of which, I guess I'll just write it over here, either cause vasoconstriction or vasodilation. So that's hormones that are altering diameter. Okay, so that's a broad overview. We're going to do nervous system first, and then a separate video on the endocrine, those long-term effects.